Introducing Advantech X Factor, a new premium subflooring with a built-in barrier for job site durability with Advantech brand's signature strength and stiffness. So whatever the expectation, go beyond with Advantech X Factor.
Welcome, everyone, to the UnBuild It podcast. I'm your host this week, Pete Yost. Sitting to my left, stage right, is Steve Basic. Hello. Sitting to my right, stage left, is Jake Bruton.
Hello, hello.
And we are
port and starboard.
Fired up. I almost said an F word.
Buckethead.
Today's topic, whether you like it or not, is loads. And when we talk about loads, we are talking about...
I'm glad we're sitting down because I took a load off.
It's going to be a heavy topic.
Whoa. What do we mean when we talk about loads? Well, we're talking about space heating, space cooling, and then the other loads are appliances, lighting, plug load. Did I miss
So these
one?
are energy loads, not structural loads.
Energy loads, right.
Okay. So we're not talking about BTUs.
We aren't talking about
cooling,
BTUs?
or we are?
We are.
Yeah,
That's what he said. What I'm saying is we're not talking about pounds per square foot.
This is clearly a heavy topic. I'm going to go back. We are talking about energy loads, and we have two loads.
Or environmental load. No, that's not really. Environmental load is not.
I don't think so.
Yeah, let's not use that.
So we're talking about space conditioning, which is heating and cooling, and humidifying and dehumidifying on the second sort of level. But then the other loads are appliances, lighting, plug load, and I feel like I'm missing one. I can't believe it. Aren't there 4 other loads besides space conditioning?
I'm going to defer to Steve on this question.
I don't know.
Steve wasn't listening.
Yeah, I'm overloaded.
Well, let's do it this way. When Steve and I were working together in the Building America program,
Yes.
we got to energy efficiency levels of the enclosure and the mechanical systems that we weren't getting a very good return on the dollar. And so DOE said, I think it's time that we turn our attention to the quote unquote other loads. And that scared the hell out of the engineers in the group, because the way that you improve space conditioning loads, heating and cooling, is you do a better job with the mechanical systems and you do a better job with the enclosure. And that's stuff that engineers can control. But the other loads,
the crap you bring into the room and plug in,
all the occupant driven loads, that scared the daylights out of them, because how are we going to manage those loads?
you and your 12 dogs.
Are they?
They're
I guess they are occupant.
They're part of the.
We're not going to get into
How do we plan for that?
Pets, are we? Is this a safe space? So,
if you want to know how cold-hearted Peter Yost is, ask him about his dog the next time you see him.
sorry. In my defense, I grew up with 10 brothers and sisters. There wasn't a lot of resources left for the auxiliary loads, which is how I refer to pets, auxiliary loads. I sure hope that Jake's wife, Rebecca, never hears this conversation. Anyway, so this is one of the main points, because when we talk about our work in optimizing building performance, we're almost always talking about the enclosure and the mechanical systems. And
BTUs.
And in BTUs. And so let's talk about the other loads a bit, because those are the ones that are harder to address. But once you do the best job you can on the enclosure and the mechanical systems, you have to turn your attention to the, quote, other loads.
This topic obviously warranted a podcast, because it's taken us 10 minutes to get through what we're going to talk about. And provide clarity there, which I don't really think we've been successful at even. So, but I will say this. I think you can build a house far better than the conditioning world provides equipment for. Meaning that a lot of the heating and cooling companies want to put in larger, less efficient systems than having more micro efficient systems.
And we have had a problem that if we get the building loads low enough, space conditioning and heating, if it's a small number of houses, a lot of the mechanical system manufacturers saying, hey, it's really nice that you want a 1.5 ton unit, but why would we make those? Because how many of those are we going to sell?
And I remember, it might not be the case, but there's one of the major manufacturers. They manufacture the furnaces in Texas, and I remember going from like a 3 ton to like or 1.5. They would say, well, we have those, but it's going to take longer to get, and they cost more because they weren't the commodity item.
Right.
And it seems crazy that to get something smaller, less productive, costs me more money. But it's because they're just not the one on the market.
And it is interesting, too, that I think a lot of the early movement towards smaller units, smaller capacity units, came from overseas, particularly from the Orient, because dwelling unit size there was a lot lower. And so regardless of how energy efficient the enclosure was, there were smaller units available.
But even when we did the Roy Passive House in 2014, 14, around there, right? The cooling load was half of the smallest mini split we could purchase at the time.
Yep.
And so again, like you go to Mitsubishi and say, we don't need 9,000. We need something in like a 1,200, 1,500 range for a small house.
Crazy low.
Can we get these systems? And they have been working on it since then. And we have those ceiling cassette systems and all of this. But I think we can build certainly a better house than what we can do that, which again impacts all of these other loads too, because we've taken the efficiency of the building envelope beyond what we can get equipment for. So looking at efficiencies in other areas is kind of the next turn.
So before we move on to the quote unquote other loads, and I just remembered the fourth one, which is embarrassing as hell because it's the biggest of the water heating. Yeah. The biggest.
I was going to say that. I was waiting for you to catch up.
Yeah. Well, I appreciate you.
Same here. Obviously. Same here.
Yeah.
It's nice that you're being, really super tolerant with me because my wife says that's an important part of dealing with me.
And dementia in general.
I think I've forgotten what that word means. All right. So are you ready to move so there are definitely issues in optimizing mechanical systems with really high performance enclosures. And a lot of it has to do with sizing. A lot of it has to do with the temptation to try to have one piece of equipment do space heating, space cooling, ventilation, and dehumidification. That's been a real challenge.
So, yeah, well, and
we're clearly not ready to leave this topic yet, right?
No. I have two smaller points. One, it's kind of like the concrete one that we had, and this might get posted before that, but who knows? But anyways, perspective, right? Like every one of my clients wants to be able to walk in any room in the house and basically control the temperature and everything in that one room.
Yeah.
And so there's that requirement and perceptive requirement. And then there's also the ability for distribution, right? Like how do I get heating and cooling into all of these spaces efficiently? Like I know we can duct it and get it all in there, but even then when you do ducting, it's like, okay, how do we get the ducting in? And especially if it's like a slab on grade house or something like that. But I'm doing a really interesting project that we took on. It's down in Tennessee. I say barn dominium, but it really isn't. But it is
barn dominium.
Yeah. So
is this the lack of Peter being on the internet? He doesn't know that term.
Yeah. So it's basically like a barn house.
Got it.
Okay. But this one has got this light monitor that goes down the middle. And John is probably going to listen to this because he's a very avid follower. And but the monitor walls come down inside the bedroom walls. So you have this, say, 4-foot hallway that goes down the middle of the building. The monitor walls are at like 6 or 7 feet. So I can be in the bedroom and walk over to the wall, look up, and I can look up into the light monitor.
I'm missing what light monitor means.
Light
Sorry.
monitor is like when a barndominium goes up and then there's windows.
Oh, okay.
Small
Sorry.
roof. So it's like that continuous clear story.
Continuous
skylight.
cupola sort of thing almost. Yeah.
Right. So it's
I didn't know that term.
Monitor, yeah. And so you can walk literally in the bedroom over to the wall, and you could have somebody on the other side of the wall in the hallway look up, and you're both looking up into the light monitor. So obviously there's that acoustical connection that you have to agree to. But this house is basically air open.
One room.
Right. Like you could put a mini split anywhere in that light monitor, and every room in the house
will communicate.
Will communicate with it. And and I'm still like, every time we meet, he's like, well, what do you think? And I'm like, John, honestly, I'm still learning like what to think, because I've never been forced to think with this level of access.
Yeah.
Right. Because it's far beyond. Usually we're working in the other side of the spectrum. And how do I solve this problem? Because I have no access. Here, I have ultimate access.
And this is a good segue to the last topic I wanted to address in terms of these space conditioning loads, is that I think that ideally people would like to be task heated like we do task lighting. In other words, we set up lighting for background, for tasks, and then sometimes for cosmetic accent, like lights for particular pieces of art. And if you approach lighting that way, and you're a lighting engineer, then you're applying the aspects of lighting to specific needs rather than just trying to do the whole building. If you could do that with heating and cooling, if you could tune it.
Well, imagine being able to sit down when you said that, I'm thinking, well, imagine being able to sit down on my couch. I'm an older person. I have leg circulation problems. I put my feet on the floor, and there's a 2x2 radiant floor panel embedded in the flooring where I get immediate heat, but it's not conditioning the room.
Exactly.
The way my wife drags a heating pad around with her.
Exactly. And if you could find a way to space heat and cool people as opposed to spaces, then you could drop the background temperature, kick it
5 degrees,
kick it up in the summer, kick it down in the winter, and you would decrease the delta T across the space, particularly well suited to this big open space.
I'm surprised furniture manufacturers haven't figured this out.
Well, it's funny you should say that, because there's a laboratory at the now I'm going to
never heard of that place.
There's a lab
at the
There's a lab out in Berkeley.
That's like the I don't know restaurant.
LBL?
Where do you want to go?
No.
The I don't care restaurant.
Anyway, I'll make sure I put it in the resource for this session. But there is a research organization that has been fine-tuning thermal comfort measurements, because ASHRAE standard 55 for thermal comfort, that was done by a bunch of Scandinavians.
Well, we do it in cars. I can get in my car in the morning, I can hit the switch, and I can heat up my steering wheel so my hands are nice and warm, and then I can heat up my seat. And you know where this historically really hit me? Growing up, we'd go snowmobiling. One of the coolest things ever to happen to snowmobiles was heated handlebars.
Heated handlebars, yep.
Because our hands would always freeze. And I remember the first time that came out, it was like, oh my God, I went from driving like a Hyundai to a Cadillac.
Yep.
Just because there's a little wire that goes in the handlebar to heat my hands up.
And you've given me the window my brain needed to remember. It's the Center for the Built Environment. That's the research organization. And the funding for their research to fine-tune the understanding of thermal comfort for humans is coming largely from the automobile industry. It's being double purposed to serve with how can we, because in commercial buildings, office buildings, the facilities manager is always responding to two people. That person who is too cold and that person that is too hot. So here they are flipping environmental controls of spaces.
Well, they do it on mattresses too, right? Because you can buy those mattresses where you can dial in one side temperature versus the other.
So if you could transfer that idea to task or people conditioning as opposed to spaces, you could make thermal comfort better and overall energy consumption less. And that research is largely being funded by the automobile industry, but it's spinning off into how might we heat people and cool people as opposed to spaces. It's fascinating research.
But I think furniture would be huge.
And it turns out that if you look at the distribution of cold and heat sensors across the body, if you keep a person's forehead, their hands, and their feet temperature controlled, the rest of your body really doesn't give a crap. So if you focused on that.
Well, those are the places where you probably have the largest surface area to the least amount of fat.
And you need the sensitivity there. When my wife and I turn down the heat in the house, the thing that there's the trouble with me is my hands. If you can keep my hands warm, I can tolerate much lower stress.
He's got home mittens, is what he's got. He's got house shoes and home mittens, house Crocs and home mittens.
I knew this was going to come back to my
They're knitted. They're like Bernie Sanders knitted mittens.
Oh, my word. Anyway, we've succeeded in what we were halfway through this podcast, and we haven't gotten to the other loads yet.
What is the next biggest load?
After space heating and cooling, generally hot water. Very dependent on number of occupants and
source
habits,
Well, and source too, like what you're using
to generate.
So we can talk about my house. I use it as an example because I have a good understanding of how it operates. Our water heater is a Sandon heat pump that the water runs to the outside and it has an outdoor cassette, just like our mini splits have, and the little yellow Energy Star certified sticker that's pasted on the front of it, I think says $80 a year. I'll have to double check. I think it says $80 a year.
So you're talking the CO2 refrigerant.
Yep.
So really high
pressure.
operating pressures, but super efficient.
Yeah. And so my house, that's not the biggest load. That's not the next biggest load. Appliances are by far the next biggest load. So there's the idea of what you choose.
And so the other thing I wanted to talk about related to your house is that it's not only the efficiency of the plant, it's the distribution, right? So a huge issue for thermal comfort is how long do I have to wait for that hot water for whatever the purpose is going to be, whether it's washing your hands, shaving, or taking a shower.
And again, another good opportunity to point out that my wife does not listen to the podcast. That is like the only complaint she has about our house is that I didn't bother to put in a recirc system for the kitchen sink. The kitchen sink is actually quite far from the source. Steve and I designed it so that the source was close to the master and the other bathroom that the kids use, so that tubs and faucets, and when I shave in the morning with hot water, that it would be quick. The kitchen sink is quite far away. That's the one thing that I hear about on a monthly basis from her.
You know, it's interesting. I think part of it, because in my house, when I'm waiting for the warm water at the sink, I'll do things like clean the sink or something with the cold water. Like it's perspective again, right? In that I'll just grab the sponge and I'll scrub down the sink with cold water so that, okay, the warm water's here, time to do dishes.
Yeah.
So then Peter has a story to tell you that very, very well describes who Peter and his wife both are. What do you do with do we call it interstitial water between turning it on and it actually getting hot in your shower?
I like that. It's all the water in the hot water lines that has cooled to room temperature. And you have to flush all that water out because it's quote unquote cold. It's not cold. It's just cold hot water. And so
it fills up watering cans.
We have a bucket for the master bath shower, and we fill that bucket, and then we use that to water the plants. And we have 2 pitchers of water at the kitchen sink. One is filtered drinking water. The other has big X's at the top to let everybody know it's just cold hot water.
It's poison water.
It's just cold hot water.
And poison water.
We rinse all the food off of our dishes with that shower water. This is way too much information for
but
Sorry for forcing you to tell that.
I'm actually going to come to your defense.
Oh, this is awesome.
Because I think there's a lot of things that we could just do better that we choose not to.
Yeah.
And these might seem like really crazy ideas, but if you have a house that has a lot of houseplants, then just put your watering can near the shower, fill it up, or near the kitchen sink, and fill it with the cold water until the hot water comes, and then I know I'm preaching to the choir.
I'm so touched. I don't know what to do.
The mittens get in the way with the water.
I must say that I am a little proud that when my kids are clearing the table after dinner, they will walk around and water plants before the cups just go in the dishwasher. They know that we're not just going to dump it down the drain.
And where this comes from for me is my mother was born in Crisfield, Maryland, in a house that was about 15.
Does the street address matter?
It's called Down the Neck. There is no street address.
I just figured, why would I need to know Crisfield, Maryland? But obviously you thought it was important, so I just asked.
It's because Down the Neck was about 12 to 15 feet below sea level. And so there was a tidal drainage ditch that surrounded the whole property, and there was a little bridge to get from the road to their house.
So you had a moat.
Essentially,
castle.
Yeah.
You said a parsonage, but now you're living in a castle.
Should call that house.
Wait, we're talking about his grandmother.
Oh, it's grandmother.
Well, so you couldn't drill a well. They had to be all rainwater catchment off a metal roof, and there was no septic field, so there was an outhouse. And my mother learned how to do dishes with, 2 cups of water, and all this staged water. Like, this water's a little dirty. This water's.
I don't know if you I'm sure you did, but we just did a video. I have a house in Texas where we put in a 55,000 gallon rain catchment. All of the potable water in this house comes off the roof.
Wow. The first work on that was done by
but it's in an agricultural area.
And where is this?
It's in Texas.
Yeah.
Outside of Austin.
Yeah, it's outside of Austin.
Well, that's where Pliny Fisk did all the Center for Resourceful Building Technology. He was doing rainwater catchment systems like
you drive up, and it's like the scale of this farmland where this house is so large. You could put the 55,000 gallons. It's probably something like 22 feet in diameter.
Yeah.
24 feet in diameter.
7 or 8 feet tall.
7 or 8 feet tall.
Yeah.
But it just looks like some agricultural building that's
exactly how
Pliny Fisk sitting over by the trees.
That's really cool.
And
it's a really squat grain bin.
Or a really squat grain bin.
Yeah. So if you don't want to do these little techniques, the on-demand hot water recirculation systems means that you basically take all the cold water, move it back to the storage tank, and you do it with a fast, high-speed pump, and that you have to activate it and takes probably 20 to 30 seconds to move all that cold water out. And you're not wasting it because you're sending it back to the tank, and all of a sudden you have hot water.
And we'll be reiterating all of that kind of stuff when we talk about water efficiency too.
You hate dogs, but the other thing I do is, the first thing I do is I fill up my coffee pot and I fill up the 3 dog bowls in the morning with the cold water before the hot water comes.
Very cool.
So then after water heating and space conditioning, where does the load in the house
so
go?
now you're in a bit of a quandary because major appliances are definitely next.
Well, they are, but what's interesting is I don't think, we did Dan Roy's house and he monitored every circuit in the house and every device.
Did he have a dashboard system?
It wasn't. It was, what are those collars and stuff that you put on?
So they're amp rings.
Yes.
Okay.
In the monitor.
Yeah.
The thing that drew the most power was his cable box.
Never turns off.
It never turns off, and it was worth twice the energy of the refrigerator.
And those suckers, you think about the cable box being completely slotted on top to let all of that heat.
It's hot as hell.
Yeah.
And it was worth 2 refrigerators.
I would be curious as to the actual load coming from that.
Yeah, because he did say it, and I don't
refrigerators actually draw really the new efficient ones, and that's not that big of a draw.
Right.
So my personal house, we're somewhere in the range of, I think the lowest we've seen in the last year was 910 kilowatt hours a month. And maybe the highest we saw was 1,300. And the 1,300 was an incredibly cold month where we had company and we were here all the time. And I was trying to figure out, without having to buy a system, what we were paying for certain things. So I started looking at the Frigidaire fridge and the deep freeze that we have from Frigidaire, what are they predicted to use? And the thing that I couldn't find online was our KitchenAid ice maker. So we bought a freezer for the kitchen that doesn't have an ice maker, doesn't have the door. We weren't sure that we wanted the ice maker out of it. My wife was very adamant that she wanted a
We got a very
standalone
efficient ice maker. It's called Ice Cube Tray.
Yep, there you go. So, but mine doesn't involve labor. So after looking for quite some time, I phoned KitchenAid, and KitchenAid told me that the ice maker that we have could be as much as 450 kilowatt hours a month.
Huh.
So like literally half of my energy usage could be the freaking ice maker that I didn't
and just
want.
say,
There's like 10 comments that I want to make that I cannot make.
but if you're at 10,000 or 12,000 kWh per year or less, that's pretty remarkable for climate zone 4. That's
For a
damn
large
good.
house that has almost 24-hour occupancy too, because we have an office here.
Right.
So, and I will also note that we bought one of those inflatable Coleman hot tubs.
That's some Missouri crap.
I need.
There.
Yes, it is. I need.
Sorry, I had to get one of them out. My mind is overloaded. So
I paid attention to our electric bill. It more than doubled our electric bill. Heating like 200 gallons.
What
of
I
water
want to see
all
is
month.
Pete lounging in that with his Crocs sitting.
Well, you should have been
outside
here.
of The hot tub.
You should have been here last night. Pete said, "Who wants to get in the hot tub?" And everybody went, "We're going to bed." Snapping the towel as he's walking out the door. Splish splash. See you guys in the morning.
So let's say that it's pretty easy to do a good job on appliances. Energy Star has great information on, the ratings as developed for each of the different appliances. What's interesting to me is that when you talk about the cable box, plug load is by far the largest growing load in the building, because we're doing a great job with appliances and hot water and such, but the plug load just keeps going up.
Well, and it's occupant controlled too,
It is.
right? Not that,
But our
temperature in the
devices
room
are
and hot water is occupant controlled for the most part. But
Yeah.
but it's again, I think it's perspective. Like my kids had no problem leaving every light in the house on. Right, walking
Sometimes
out
I
of a
feel
room
like-
and leaving the light on. I'm like, can you just turn the light? You just walked out of there. Can you just turn the light off? Oh, what? Just turn the light off.
yeah.
Sometimes I feel like 90% of being a dad is walking around turning lights off.
Yeah, I remember my dad used to smack me for, like, if I had the refrigerator open for longer than 10 seconds.
Yeah.
I think you push the door closed and go, think about what you want, then open the
Yeah,
door.
then open the door. You know what the hell is in there. Why the hell you got to stand there? Close the damn refrigerator.
So
I just have to go ahead.
plug load. I used to have a friend. He does not work there anymore. He used to work in building services at the university, and he was in charge of a dorm. He was in charge of 2 buildings, and that was it for maintenance and for upkeep. And I'm paraphrasing because it's like 10 years since I had this conversation with him. He said in 1960, when the dorms that he was in charge of were built, the average student brought 2 items to school with them that plugged in. And most of it was an alarm clock. And then they averaged out to like hair curler, hair dryer, lamp, things like that. And when we had this conversation, like I said, it might have been 2012, 2013. He said the average college freshman was bringing 24 items that needed to plug in.
Wow. Yeah. So real quickly on lighting, really important that we separate out background from task to accent lighting. But the move from incandescent to fluorescent, but most importantly to LEDs, that has completely changed the role that lighting plays, because
In load.
we can so efficiently get adequate task.
When we had incandescent lights, I remember a kitchen where they actually had a heating load in the wintertime. Because there were so many recessed cans in the kitchen that they actually had to calculate it as a heating load in the middle of winter.
So
Why is the light bulb the one thing that everybody just bought into and went, yep, I understand if I buy the more expensive one, it's going to cost me less than the wrong one? Every other aspect of our buildings, it's pulling teeth to get people and builders to understand that investing in it up front can be a good thing in the end. But light bulbs caught on in a matter of a couple of years.
Probably part of it is where do they get sold, right? Like if you could put something in Home Depot or Lowe's and market it successfully there, like you can overturn perspective pretty darn quick.
A lot more market conversion power.
Right. The problem with builders and stuff is you go to your lumber yards and stuff and you're just reluctant because that marketing campaign isn't as successful there.
One final thought for me on these other loads is that the milder the climate, the more these become dominant. Except I'm doing some work on high performance buildings in California.
Explain that just a little bit for the accountants in the audience.
Just that if your space heating and cooling.
So if we're building in San Diego, lighting and hot water, because lighting and hot water isn't climate tuned. The requirement.
The space conditioning loads are low enough that the other loads are a bigger piece of the pie.
Now, I have a question for you that you might know, because I think you living in Alaska. Like, does Alaska's plug load increase given that, 6 months of the year they're in total darkness? Now, obviously they're going to be in total light, but we still turn lights on in the light.
I think there's probably
street lights are on all the time.
Yeah, I think there's probably, you're going to love this, Steve, the relationship between those loads in the winter and getting loaded in the winter, there's both a significant increase.
So they sleep well.
A lot of alcohol consumption.
Also,
and
to
other loads.
To break the fourth wall here and let you in on how nitpicky some of our listeners are, water heating is climate tuned because of ground temperature. There is some difference. It's minute. I agree with you.
That's
I would call it
minute. That's a blip on the radar.
Those are some of the kind of emails that we get because people pay so much attention.
But in a lot of these milder climates, one of the most important things you can do in terms of space cooling loads is shading. The opportunity to reduce air conditioning loads by using shading devices dwarfs almost any other approach.
I would think water heating is probably climate tuned more in the sense of if I'm in Texas and I put the water heater in the attic, it becomes more of a challenge or less of a challenge to heat that water.
Remember that?
Yeah.
Steve and I were in a Houston attic at 2:00 and there were two 40-gallon tanks, for the domestic hot water.
It's these probably never turn on.
I said, this is how Texans do passive solar. They just put the tanks up in the attic. It was 168 degrees there.
It was just a plastic drum.
He had to go, just as a side note, he had to go up into that attic 3 or 4 times. Every time he came down, he would literally close the attic and go, damn it, I left my glasses up there. And have to pull it down, go up, crawl across this 168 degree attic. Every time he came down, he was just drenched.
I was soaking wet the whole time. So I will say that there's a number of great resources we can post on this whole issue of these other loads coming from the Department of Energy. But we need feedback. If these loads are occupant dependent, we've got to get a good way. Dan Roy's got a system, but he's an engineer and he's retired. But we've been looking for good dashboards for these loads for a long time, and we still don't have them cost effective. We really need those to get these other loads down. That was fun.
Are we almost done?
I think we're overdone.
All right, so I have a question for both of you.
Overloaded.
If a jockey wears jockey shorts and a basketball player wears basketball shorts, what does the president wear? It depends.
Is that a president-specific joke? Maybe don't answer that, actually, now that I said that. Okay.
Thank you, Steve.
You're welcome.
Thank you guys for watching today. Thank you for listening. Don't forget to leave a 5-star review. Don't forget to subscribe. Smash that button, as Steve would say.
Smash.
Thank you, gentlemen, for joining me. Till next time, have a good day.
See ya.